So I just have a couple of slides here to go over just some basics about smart design. So we'll talk about that, and then we'll jump into an example and go through some demonstrations of how it works and some of the options. So the smart design feature in EasyPower, the option for smart design, is it's essentially a rule-based sizing of equipment and cables, and uses tables that are predefined in the library. So we call those design sheets. And so based on whatever's in the table, EasyPower will do load calculations, voltage drop calculations, and that sort of thing, and make selections from those tables, whatever particular design sheet you selected. Now this is based primarily on satisfying the National Electrical Code requirements for load calculations and equipment sizing, breaker sizing, conductor sizing, and that sort of thing. So the things that can be sized in smart design are buses, like a panel board bus, MCC bus, the main bus, that can be sized. Cables can be sized. Protective devices, breakers and fuses, those can be sized in smart design. And transformers. Again, it has to be something that's in the design sheet. We'll take a look at that and see what's in there. So at this point, the smart design is limited to low voltage systems up to 600 volts. So it will size, if you have a transformer that's going from a medium voltage to a low voltage and it's in the design sheet, EasyPower can size that transformer. But it's not going to be able to size any of the medium voltage like the transformer primary fuse or anything like that. If you select that and run smart design, you'll get a message saying it doesn't do medium voltage or high voltage. So at this point, it's limited to low voltage systems. As far as the requirements, in order to run smart design, obviously you need an EasyPower one line with your equipment defined. And it has to have a source, and the reason for that is that we do short circuit calculations. We also do voltage drop calculations during smart design, and so we have to have at least one source of power in order for the program to run those calculations. In order for it to size things like feed the breakers and the cables, it needs to know what the loads are. So ideally you would have your loads defined in some manner to represent the loads you want in your final system for the program to run an accurate design calculation. There is an option to size based on the downstream equipment bus ratings. We'll take a look at that as well. So if you don't have all the loads defined, but you know you want a 200 amp panel board in a particular location, you can define that 200 amp bus, and the program will use that 200 amps to do the sizing of the upstream breaker and cable. You really should have the approximate cable lengths in the model, because again, it does try to do the voltage drop calculation. If the voltage exceeds the limit that you set, let's say it's 5%, then it's going to upsize the cable until the voltage drop is within those constraints. If you do not have a cable length entered, the program will insert a predefined length, and you can set what that predefined length is in order to do the calculation. The default value for this is 99 feet, so we'll see an example of that here shortly. You need to define what the bus represents in your model, so the program needs to know if that bus is a panel board or switchboard, switchgear, MCC. It needs to know, in order to select from the right table in the design sheet, you have to tell it what the equipment type is. And we need to have the voltages accurately defined, or else the program's not going to be able to select the right equipment. So the transformers do not have to be sized, but you have to have the correct transformer voltages modeled. Okay. So let's go to this little model here. This is actually in the tutorial for the AutoDesign, SmartDesign. So we'll work off of this for right now. We'll just, you may have looked at this before, but we'll run through some examples and maybe look at things in a little bit more detail. So I have this bus 3 here, which is my main distribution panel or board or whatever it is, and I have 5 feeders going out in the main breaker. So the way that the SmartDesign works is I'm going to select the things that I want it to attempt to size for me, and then it will run the SmartDesign, and it will update what's in the file with the appropriate sizes and types of equipment and cable sizes as it determines. So just to show you quickly how this works, and then we'll come back and look under the hood and see how it came up with this stuff. So we'll just start simple here. We're going to take a look at this feeder down to panel 3. So if I just hold down my shift key, I can highlight the feeder, the breaker, and the panel. So the way the program does this is the same way you would do it per the NEC. You're going to look at the load down here, and it sizes the breaker, and then based on the breaker size, it sizes the cable. So you need to select both the cable and the breaker if you want it to size it correctly. So once I've highlighted what I want it to size, I'm going to go to my AutoDesign button here and just click and say Run AutoDesign. So you can see when I do that, it's inserted a cable here, my number 2. It plugged in 99 feet for my cable length, which I did not have a length in there before. And it said I needed a 100 amp breaker. So it's actually changed the data in my file, right? So you have to be aware of that's how it works. So there's an option to only generate a report without actually changing what's in your file. That's one option. And we also have the ability to lock anything so that AutoDesign will not change it. All right. So anytime I run the AutoDesign, it's going to generate a report. And if I go to my window, I'm going to have an AutoDesign report. So this is going to provide an explanation of how it came up with the sizes that it came up with. So here's the panel. You can see where it sized the bus here, 100 amps. And that's based on the connected load. It had 44.4 amps that we had defined in the panel schedule. That works out because it's taking the 125% of the continuous loads. That works out to 55.5 amps. So it selected a 100 amp bus because that's probably the smallest size bus that it had in its design sheet. So 100 amp bus. And then the breaker is sized here at 100 amps. And it gives you some explanation of how it sized it. And then finally it sized the cable. And it gives you the explanation here. Here's the voltage drop estimate, 0.3%, so that wasn't a problem. So anytime you run AutoDesign, it's going to generate this report. Okay, so let's talk about a couple things here. When it selected this circuit breaker, you can look at this. This is a molded case circuit breaker. And it picked this generic, which is an option we have in the library. So number one, how did it know that I wanted a molded case circuit breaker in here? And number two, how did it know I wanted why did it put in a generic breaker instead of a square D or Cutler hammer? So as far as the type of breaker, the molded case circuit breaker, that's based on the equipment type that I defined for this bus, okay? So if I double click on bus 3, you'll see that I defined this in my file as a switchboard. So this bus type, now we use this in ArcFlash to determine whether it's open air or in box and the gap that we assume. It's also used in AutoDesign to tell the program what type of equipment this is. So if I look at the design sheet we'll take a look at later, if I define this as switchboard, it's basically going to use molded case circuit breakers up to a certain size and then insulated case circuit breakers above that. So anytime I say switchboard here, I'm basically going to get molded case circuit breakers. Let's change it from switchboard to switch gear now and see what happens. I changed the bus type to switch gear, and that would imply low voltage power circuit breakers. Now it doesn't update automatically. I have to redo the auto design. If I run through the same steps again, now this time I get a low voltage power circuit breaker. Instead of 100 amps, it's 150, so I end up with a bigger cable. So what's going on is that this is probably the smallest size it can come up with in the low voltage power circuit breaker that we have in the design sheet. So this is a very small load for a 800 amp breaker. But just to show that by changing this to switchgear, it means the program is going to use low voltage power circuit breakers here instead of molded case. All right. So let's change this back to switchboard. I'm going to go ahead and rerun this. And then I'm back to my previous example. All right, so I mentioned that it's basically going to size based on the load. So if I look at my panel, in my panel schedule, I have defined my loads, all my feeders out of the panel, branch circuits. So if I go to my summary, you'll see this is the total load that it came up with. And so the code factors is this load here, whatever it is. And so it's going to base that sizing on the load that it determined for the panel. And because I selected the panel for AutoDesign, it's going to size the bus. So if I go back and look at my main bus rating, it's got 100 amps. That was not there before, that was blank. So the program said, well, based on your load, I'm going to put a 100 amp panel in there. So let's say I really knew I wanted a 200 amp panel, not a 100. Okay. I can change this and say 200 amps. So I put my 200 amps in here. Now, if I go to my AutoDesign options, which are going to be underneath the AutoDesign here. So I have this AutoDesign options. If I go to protective devices, it says size feeder breakers, and this says based on bus rating. All right, so where I have a bus rating defined, it will use that to size that feeder and breaker instead of the load. Okay, so let's try that. I'm going to pick the breaker and the feeder. I'm not going to pick the panel for right now. Go to AutoDesign. You can see it said, well, okay, that's a 200 amp bus in the panel, so I'm going to change this to 200 amps. And the feeder got bigger proportionally. But what happens if I pick the panel now? Well, because I'm allowing the program to size this bus, it's going to look at the load. It's going to change the bus from 200 back to 100, then the breaker size and the feeder size will probably go down. Right? So if you allow the program to, if you run AutoDesign on this panel, it's going to size the bus based on the load. So a couple ways around that is, like I did, I didn't select the panel. I just left it at the 200 amps. For every device, we also have a lock. So you have the ability to lock this. So if I set this to 200 and lock that, then the program will not change that anything in the panel when I run AutoDesign. So you always have the ability to lock any piece of equipment in AutoDesign. Okay. All right, so we'll look quickly at some of the other options we have in AutoDesign. Design library sheet. This is where it looks when it's doing its selection of breakers and cables and motor feeders and all that, the sizing of transformers. There's a predefined table in the library that it's looking at. And the one we're using is called generic. This option here says generate report only without changing data. This allows you to run AutoDesign and generate that text report we looked at, but it will not change any of the actual data in your file. So when we have, generally going to leave this on code factor amps. This is the NEC type load calculation. We give you some other options here. Short circuit threshold and percent. This is where if the breaker interrupting rating gets up to, what this is saying is that if I have a short circuit current of 50,000 amps, if the breaker interrupting rating gets, if that's within 80% of the breaker rating, it's going to go to the next higher interrupting rating. In other words, it does look at the short circuit rating, and it gives you a 20% cushion there. So the lines, we have a tap rule that allows you to have an unprotected tap up to 25 feet. Here's that default cable length we talked about. If there's no cable length defined, it's going to use whatever number you put in here. Then protected devices we looked at. Voltage drop. So down here it says upsize conductor if voltage drop is greater than 5%. It also does a motor starting calculation for the largest motor, and so if the voltage drop exceeds 20% for that, it's going to upsize the feeder. You can adjust these to whatever you want. If you leave this blank, it will not, just won't check that. Okay. So the other question I raised was, so we looked at why it picked a molded case breaker here, but why did it pick generic and not something else? And the reason is the design sheet. So when I looked at the library data, or the options, here's my design library sheet. So let's go see what that's pointing to. If I go to EasyPower, the big E, say open library, standard library. All right, so way down at the bottom, we have design. Go US. And here we see that same list you would see when you're picking your design sheet. So we have vendor specific. So if I pick a GE design sheet, I'm going to get GE circuit breakers basically. And here we have generic. So that's the one that we were pointing to, right? So if I go to protective equipment, so here's my switchboard, and here are the different frame sizes. So if it says, well, I need a 100 amp breaker, it's going to come into this, and it's defined as a switchboard. It's going to come here and look. It's going to say generic, and then it's going to use that frame and adjust the trip accordingly. When I set it to switchgear, that means it's looking in this part of the table here, right? So that's why I got a low voltage power circuit breaker. So this equipment type determines where the program looks. And this, it's going to have to make a choice from something that is in this list, right? So these are the protected devices. If I look at feeders, these are the conductors the cables that it's going to pick for a certain size feeder. So if I have a 100 amp breaker, it's going to pick this number 2 THHN copper, certain size ground wire. So that's where the cable sizes come from. So once it sizes the breaker, it simply goes to this list, picks out the cable size. Okay. We have similar tables for bus equipment. So if I have a panel board or a panel, this is the bus ratings that it has available. So it's going to pick a bus rating here that's big enough. It'll go to whatever size it needs that will meet the load that it's determined that is necessary. Okay. So if I were to go to let's say a Cutler hammer design sheet, the main difference is these were going to be actual breakers. Again, it's taking things that are in the EasyPower library, but in this case, they're all Cutler hammer devices where possible. Okay, so that's the difference. Now we do have pricing that's in for these devices. These are list prices. I wouldn't bet a week's pay on these accuracy of these, but you would be able to adjust these in the library if you wanted more accurate pricing data for whatever your multiplier or discount was. So we do give the ability to track pricing and also to do a bill of material with a cost estimate after you run the AutoDesign. Okay. So let's say we give the ability to add additional design sheets. And so if I look at my feeders, let's say these are all THHN. Let's say, well, I wanted to use something else besides THHN in my design for a particular project or just my standard for my company. We have the ability to copy these design sheets and create a new one that you can then go in and edit. So just as an example, if I go to this generic, I can do copy sheet. And if I come up here and right click on this, I can do insert new sheet. So I get a sheet 1, which is basically a copy of the generic, and I can name that whatever I want. Okay, so now I can go to this design sheet, go back to my feeders. So now if I decided I want above a certain size, that I want these to be something else besides THHN, I can come into this design sheet now and just change what I feel like I want to change. So if I want to make these all XHHW, I can do that, right? So I would just pick whatever I wanted to change here, and I can copy paste here. Let me see. Oh, I'm liking that. So you would just go through then and make whatever changes you wanted to make in this design sheet in the library, and then you'd have your own customized design sheet. So if you don't want to use THHN, you want to use aluminum for larger size, however you want to configure this, you can make those changes. So you're not restricted to the design sheets that we give you here, okay? So now if I go back to my design sheet options, there's going to be the ones that I just added will be here, okay? So the design sheet can be, you can add your own and customize those to anything that you want. Okay, so we did this guy, we sized this. We can also look at all the rest of the equipment. So let's just go ahead and do a total sizing here. So if I select all of this, sorry about that, including the transformer, now if I click AutoDesign, it's going to go through and size all this. All my feeders are sized, and I have my breakers are sized, transformer's been sized. So if I went to my AutoDesign report, I'm going to get a big long list of, for each device, how it determined how to size that. Okay. See, we have an error message here. Basically, this is related to the sizing of the main breaker. If I go back and look at my main, it didn't size that. And The reason is because in the generic library it cannot find a breaker that meets the requirements here. And so what it's doing is it's sizing this breaker based on the transformer. Secondary protection per the NEC. If you look at the bus, it came up with a 1600 amp bus. Okay. But the transformer is only good for what? 1200 some amps, so 125%. It's going to take 125% of the full load amps here and try to size this breaker. But the problem is in our generic library there isn't the breaker in there that meets that criteria, so it wasn't able to size that. If I were to go back now to pick a different design sheet, let's pick Cutler Hammer. Now I got to rerun this, but it takes a second. So now it was able to size that, come up with a size that it wanted here. Okay. So now I have my main breaker selected and sized. If I try to size this fuse, I'm going to get an error because it's, again, I say that's not really supported. Let's take a look at the, just if you haven't ever looked at it, the bill of material report. When I run AutoDesign, it gives me a kind of a summary of all the things that it's sized. So if you select your everything, you'll get a listing of all the different elements in your design along with the costs. Okay, I should also point out that the AutoDesign will work inside of the motor control centers and panels. So if I were to insert a new row here at the bottom, and we'll add a new motor. Let's say it's 100 horsepower. This needs to be a standard motor horsepower size, or else the program can't quite figure it out. Once I've defined that, if I right-click on this and say auto size, the program will go through, select, again, based on the design sheet definitions for 100 horsepower motor, I'm going to get a certain breaker type and a certain feeder. So it's sized all this based on the data that's in the design sheet. So I have a certain size feeder, certain size conduit, and all that. And the last thing we'll demonstrate here is the voltage drop as far as for this model. So this is 99 feet, and it came up with two 600 kc mil per phase for the 800 amp feeder. If I were to go in now and change this length from 99 feet, we'll go to something extreme, like maybe let's say 2,500 feet. Now if I rerun the AutoDesign here, and you'll see it went from two 600 kc mil per phase to 6. And that's based strictly on the voltage drop. So if I look at my report, my AutoDesign report, I go down to this cable. It's going to say this number 6, before upsizing the cable, the estimated voltage drop for the two 600 kc mil per phase was 12.7%. So it just kept increasing the conductor size until the voltage drop got down below 4.2%. So that's the 600 kc mil per phase. All right, so you can always go back and fine-tune whatever the program selected in the AutoDesign and make whatever changes you need to. but it does give you a first approximation. It looks at the code rules and applications. So it gives you a first pass or maybe a sanity check on some of the sizing. One other way that I've used this AutoDesign is for quickly sizing cables. So if I have a, say, a 480 volt bus here, just quickly put this together. I have a source that's put in something a little more realistic here. All right, so if I have some feeders coming off of here, let me just put in some cables. All right. So this size is just the default size that I have set in my settings. It's not based on anything other than that default setting. So if I were to put my breakers in here now, I'm going to set this to switchboard. So again, I'll get, switchboard. I'll get multi-case breakers. A lot of times if you're doing data collection for a study or for a system, it's fairly easy to get the breaker size. Getting the feeder size can be more difficult because of just the issue of opening up the doors with the equipment energized and that sort of thing. So let's say I know I have a certain size breaker here, and let's say it's a 90 amp breaker. If I have the breaker defined and I select the cable and run AutoDesign, it's going to size that cable based on the breaker size. So this gives me a good first approximation of what the likely breaker size is. So that is a way that you can use AutoDesign to quickly populate the model with feeder sizes that are going to be fairly close once you know the breaker size. So that's another application for AutoDesign. So just remember the design sheets where you can customize what the program is going to select from. You can lock the AutoDesign, and also you can customize. You need to select the type of equipment that it is in order for it to select the correct breaker type that you want to put in. Okay? So people sent in a couple questions here we can go over quickly. It says, will AutoDesign coordinate breakers within a manufacturer's family of breakers? So it doesn't specifically look at, it's only going to select breakers based on that list that we saw in the design sheet. So if I have a 100 amp breaker and a 200 amp breaker, it's just going to pick from that list. It doesn't select all the settings. That's really done in the auto coordination Smart PDC, which is a separate function. So the Smart PDC will try to set adjustable trip devices to coordinate, but that's not really part of AutoDesign. Other question is, does AutoDesign account for max number of conductor terminations per phase on a particular panel? And no, it doesn't get into that much detail. It's going to say, you know, if I need 1200 amps or 2000 amps, here's the feeder you told me to use for 2000 amps. It just looks at the table that you defined. So, you know, a lot of this is going to be based on how the experience and the smarts that you put into customizing those design sheets. But the program itself does not look on that. Another question about IEC and metric. So right now the program is really looking at the U.S. National Electrical Code for SmartDesign, so it's not going to work for, I mean, if you find a design sheet with IEC devices, it would select from those, but the sizing will be based on the NEC, National Electrical Code. Okay? So Hopefully that gives you some idea what's going on in the AutoDesign and how you might be able to use it. Even if it doesn't do everything 100% the way you want it, it gives you a good starting point. You can go back in, and through customizing the design sheets, you can, you can have a consistent approach between, if you have multiple people doing design, it helps with consistency, I think, between people, selecting the same size breaker for the same application. All right. So if you have additional questions or interest in AutoDesign, you can contact EasyPower, or if you have any technical issues, just feel free to call or email tech support if you're having any concerns about how to use AutoDesign. Okay, well, I want to thank everybody for sitting in today, and tune back in a week or two, and we'll have another webinar. So thanks, everybody. Have a good rest of your day.